Hi, I'm going to show you guys a precipitate reaction by combining two aqueous solutions to form a precipitate in the solution. So what I'm going to do is I'm going to make a solution of sodium sulfate, which is this one, and lead nitrate, which is this one. And when I combine those two solutions, we're going to create a precipitate, and we're going to find out what our precipitate is. So first I have to make these solutions. First one I'm going to make is the sodium sulfate. So here's my salt, my sodium sulfate. Gonna pour about 100 milliliters. So there's our sodium sulfate solution. Now we're going to make our lead nitrate solution. Water in it. Looks like that's all dissolved. So there's our lead nitrate solution. Now what we're gonna do is we're gonna combine them and see the precipitate that forms. Okay, so check this out. We dropped the lead nitrate, and now we're left with this cloudy white stuff in our solution. What that is lead sulfate. So that white precipitate that's sinking to the bottom is lead sulfate, because what happened was a double replacement reaction. Remember, we had lead nitrate and sodium sulfate. So the sulfate ion and the lead ion, lead and sulfate combine, and since they are not soluble, or they are insoluble in water, they could not form an aqueous solution. So that's why it formed a solid precipitate. And that was that white stuff that just couldn't dissolve. Check that out. Now it's like a white, milky, cloudy solution, which by definition is not really a solution, because there's still some undissolved, well, now there's undissolved solute, and that is the lead sulfate that's making it all cloudy. So now it's no longer transparent, and no matter what I do, just like before, I cannot dissolve the rest of this. This is solid. Now it might not look solid. Look at this. You might say, oh, that just looks like all liquid. But in reality, the white stuff is a solid precipitate, because no matter what I do, it cannot dissolve. And if I let this sit for a couple hours, all that white precipitate will settle to the bottom. All right, so check it out. This beaker has been sitting here for over 24 hours. And notice how all the white precipitate has settled to the bottom of the beaker. Check this out. Most of this is transparent liquid, but the bottom is that white precipitate that we saw earlier. And it has settled down to the bottom because it did not dissolve in the water. And if I take this stick and I just poke it a little bit, you'll notice that as I stir the precipitate, it becomes suspended in the water. Suspended just means that it just floats in the water without really being dissolved. This, it may not look like it, but it is solid. And there's even some solid precipitate at the end of this stick. That's the white stuff. Now I just want to clarify that it is not dissolving, but since I'm mixing it, it's being evenly distributed. But if I let this sit again for another day or two, all that precipitate will settle to the bottom because it will not dissolve in the water. And that's what a precipitate is.